Hello guys, welcome to Hardcoded. In this video, we are going to see the Leetcode problem number 2131. So let's get into the question. Leetcode 2131, longest palindrome by concatenating two letter words. So the problem statement is, we are given an array of strings, words, and each element of words consists of two lowercase English letters. So create the longest possible palindrome by selecting some elements from the words and concatenating them in any order. So each element can be selected at most once. It means we can either select the word or skip the word. So return the length of longest palindrome that we can create, and if it is not possible to create any palindrome, we return 0. And a palindrome is a string that reads the same forward and backward. So let's get into the approach. So first we will define the problem. So firstly we need to know what is meant by palindrome. So palindrome is nothing but a word which when reversed returns the same word. So reverse of word. This is the palindromic word. So this word is considered to be a palindrome. It can be for example A B A or a word Malayalam. So Malayalam, mom. These words are palindrome, and these three are even length palindrome. The palindrome can be two length. One is even. That is sorry. One is odd. So these three words are odd length palindrome and even length palindrome. So when we reverse it, it will be the same. So these are the this is the even length palindrome, and goes on. There are many possible ways. So this is all about palindrome. So next is they have said that they will be giving a array of words, array of strings words. So input will be words. They will give words. So the words, each word will be two length. Each word will have a length of 2, and we can select either select or skip. So select or skip. So we need to select or skip each word, and any order doesn't matter. So you can choose them in any order, and finally we need to return longest possible palindromic word. Longest palindrome, let's call it as yeah, it's a word. So longest palindromic word. So this is what the output is going to be. So yeah, we have fully defined the problem. So let's get into the approach. So approach. So how can you approach this problem? So yeah, so we can see, let's consider a case. So mean two letters, so two words. So A B, yeah, A C and B A. So when we consider these words, so what is the common pattern in the palindrome? So the common pattern in the palindrome is the start word and end word, sorry, start letter and end letter are same. So when you consider a bigger example, so here so when you consider this example, you can see that yeah, it has a pattern of matching from right to left. So it will be matching from right to left. This is the pattern. So how can we apply this pattern in our problem? So when we include the word AB, the final word should be the reverse of the word. So it should be BA. So when we consider this, we have having the pattern. So now we have formed the four length word. So answer of this problem is 4. Yeah. So we are going to find the reverse of each word. So here we have found out. When we consider this extended test case, so let's say we have further A, B, B, A. So what will be the answer? So firstly, we can see we have AB. So we have AB, and reverse of AB will be BA. So we have included BA. So again we have AB. So we include AB, and we have BA. BA. So we'll check whether they are forming palindromic word. So yeah, these are forming. So length is 8. So how can we find this combination? So this is the first one. So how can we found? So we iterate over the complete array. So firstly we'll iterate over the array and check if the reverse is available or not. So the reverse of AB is BA. So for initially we haven't met the BA. So we just continue. So yeah, we'll go to AC and we'll check whether CA is available or not. So we haven't met any CA, so we'll continue. And first we will have an answer variable as 0. And we'll go to BA and we'll check whether the reverse is available. So AB, yeah, it is available. So we'll just cancel out and add them to the answer. So yeah, we have added the current word and the reverse word to the answer. And we'll move on and we'll check whether BI is available or not. It is in the backside. So it is not available since we have there is a BA which but we have included into our answer. So we continue on. We'll meet BA. So we'll check whether the reverse of the word. Reverse of the word BA is AB. Whether it is available in the previous indices or not. Yeah, it is available. So we'll include both the words, current word and the reverse words, which will be leading us to answer to 8. So this is it. This is the approach. So there is a corner case in which you have to take care of. So consider the test case A, B, B, C, C, B, A, B, D, D, and let's say A. So consider this test case. So let's index them 0, 1, 2, 3, 4, 5, and 6. So when we consider this case, is the word array. So firstly we'll check whether the reverse of the current word is present or not. Yeah, it is not present, so we'll continue. So when we reach here, we'll check whether the reverse of current word is present or not. It is not present, so we'll continue. Same goes here. So we won't find the reverse of the current word. We'll move on. Same goes on. We are not having AB in the previous indices. So we'll continue our iteration. We have made the AB. So reverse of AB is going to be BA. We'll check whether the word is BA is present or not. Yeah, it is present. So usually the answer will be 0, right? So we'll add the current word and the reverse word to the answer, which will be 4. And we'll continue. We'll check whether DD is present or not. It is not present, so we'll continue. And we'll check whether word AA is present or not. The reverse of AA is AA. Yeah, it is present in the previous index. So we'll just add the current word and the previous word. So the answer will be 8. So we have found out, and yeah, we have found out the word answer, but there is a slighter longer length possible. So which is the answer? So firstly we'll form the sequence, form the word using the selected words. So let's take AB, so BA. So we will take these pairs BA and AB, and we'll take other pair which is AA and AA. Yeah, we have found a perfectly valid palindrome of length 8. Is there, can we extend the answer further? And the answer is yes. How can we extend it? We can just add the BB to the selected formed palindrome. So now, now to the palindromic condition remains same, since when we reverse it, it will be same word. So answer will be 10. So how can we find this? We can just find this by checking for a pair. If the pair is odd, the count of pair is odd, we just add it up to the answer. So if the count of a pair, that is a palindromic pair, if the current word is having same character, same consists of same characters, and if it consists of same character, we just add it up to the answer. If it is odd, we just add the word. Only one word is possible. We cannot add BB and CC. So this is not possible. So how can we approach this? So we just have a set. So we'll have a set and store the words and frequency. So sorry, we'll have a map. So we'll have a map and store the. We can even use set, but we are going to use a map here. So map of string and the corresponding frequency, which will be integer. So we are going to use the map of string and integer, and when we let's consider the test case. Yeah, we are taking the test case. So firstly, we write it over the map and iterate over the given word array, and we'll add the we check whether the reverse is available or not in the map. It is not available for initially, so we'll just insert the current word and increment the frequency of 1. So yeah, it is 1, and we move on to next word and we check whether the reverse of the current word is present or not. It is not present, so we just add ty to 1. So yeah, we'll extend the test case further. Let's have AA and CC and also AA. So yeah, I have made. So we'll check whether the word YT, reverse of YT is available or not. Yeah, it is available, and we'll check for the count. It is 1. So we'll add 4. So we'll select the word, reverse of the word, current word, and current word. So our answer will become 4. So we move on to next word. So the word is LC. The reverse of word is LC is CL. CL is not present, so we'll add the current word LC with frequency 1, and we move to CL. Next word CL. So yeah, CL's reverse word is present. So we just select the current word, the reversed word and the current word to answer. It will be 8. Now we go on to AB, and the reverse of AB is BA. BA is not available, so we just increment the current word's frequency to 2. So we move on to next word, and yeah, we have AA. So when we have AA, the reverse of the AA is AA, but it is not present. So we'll add the current word and also the frequency. So we have next we'll meet the word CC. The reverse of the current word is not present, so we'll just add the current word. And finally, so when we add the word which is having same characters will have a boolean value as is present. We'll first initially have it as false. And why do we need this is present variable? So it's nothing but consider. So I'll tell it later. So we'll just add cc, and if the current word is having the same characters, we'll check whether the frequency is odd or not. If it is odd, we just make it to true. So okay, yeah, so we will have CC as 1, and after that we'll move on to AA, and AA as the reverse of AA is AA, and yeah, it is present in the map. So we'll take the current word and the reversed word and add it to answer. So it should be 12. So currently the answer is 12, but is this the final answer? No. We can also add CC, right? So the will form the current word. So I have choose TY and finally YT. So LC, CL, this pair, this pair, and this pair, and AA. So what can we place here? So we can place CC here, which will be so we'll get the complete array. So complete the longest answer possible. So how can we find whether the single word which can be entered into the center of the formed palindrome or not? So how can we find this? So we'll have integer array. We can call it as ARR, which will be having size as 26. So this array can be specially used to keep track of the palindromic words. Palindromic words are nothing but words which are itself a palindrome. So palindromic words. So we'll keep track of palindromic words. So zeroth index can be used for AA, first index for BB. So it's go on till 25th index, which we can keep, which will be representing for ZZ. So for each time when we encounter uh, value that palindromic word, we just increment the value. So we increment the value of the represented index. So finally, when we get the answer, so firstly we'll just have 12, right? So after this, we'll iterate over this array and check if any of the shell, any of the value is uh, odd or not. If any of the value is odd, it can be which in model by 2 will return as 1. So any of the value is odd, we just increment 2 to our answer. So this is the approach. If you are not clear in this approach, you will be very clear in the coding session. So let's get on to the coding session. So firstly, we'll get a map of string and integer. So let us frequencies. So we'll move on to each words. So this is a enact follow. If I'm moving on into it, let's have two variables int answer. The answer will be 0 and we'll create a new array. So the array of new int of 26 characters, 26 cells. So yeah, as I mentioned, each cell will be representing each pair of lowercase English alphabets. So firstly, we'll check the reverse. If the word is palindromic. So we have a helper function to check whether the given word is palindromic or not. If it is palindrome, we'll increment the, we'll find and get the character, which will be first length, first character. So we'll just increment the value at the character minus 97. So we'll be incrementing the value, and if value at current palindromic word is equal to 2, we'll increment the answer by 4, because we have formed, let's consider AA and AA. Firstly, we'll be having, when we met AA, we'll have 1, and again we met AA, we get 2. So in this case, we'll take the current pair and add it to answer and make the answer to 0. So we'll continue, and this is for the palindromic word. Or else, so we don't need else since we just continue here. So firstly, we'll find the reverse word. Let's call it as reward. We have a helper function to get the reverse of the current word. So we'll get the frequency of the reverse words. So frequency will be frequency start get or default reverse word comma 0. So if frequency is greater than 0, we will increase the answer by 4, and we'll update the frequency of the current, the reverse word. So we can start with reverse word comma frequency minus 1, so it will be 0. So or else we'll just increment the frequency of current word comma 1. So this is it, and finally we'll iterate over the uh, array, which we have used to represent the count of palindromic words. So palindromic words will be AA, BB, CC, DD, etc. up to ZZ. So we're going to check for the central word. So we write it over the array using NH follow. So if A is any of the words, any of the values 1, we'll increment the answer by 2 and break out of the row. So finally return the answer. We can check this by using a simple condition, which is if words first character is equal to words second character, and the word is considered to be a palindromic, since the given words will consist only of 2 lowercase letters. You can just use it as it is, and we can also replace the reverse function by using word dot character at 1 plus word dot character at 0. So we have replaced the helper functions. So let's check with sample test case. So it's working fine. Check with other test cases. Sorry. So let's check it up. Let's submit it up. So actually I got a mistake. So the frequency should be updated, incremented, right? So we get the frequency of current word and we put the increment the frequency. So let's okay. Let's submit it up. Guys, actually you have also made a mistake there. We need to decrease the frequency of reverse vote by 1. So let's check with the sample test case. Test case which we have gotten wrong. Yes, working fine. So let's submit it up. Accepted. And the time complex of the approaches out of uh, n, which is votes dot n. And the phase complexity out of which will be 26 into 26 in this case. Since the map will be storing maximum words like so all the pair of lowercase letters, so it will be a b a etc. So maximum words will in the stored in the map will be 26 into 26. So it is a constant space. So that's all about this video, and the approach for this video is hashing and string manipulation. And that's all about this video, guys. Thanks for watching this. Have a great time.